This tutorial will be in two parts. So first I will have a 20-minute presentation to give you a bird's eye overview of the Furhat SDK and the different ways you can program. So it will be, just an overview. And then Nils will go into the more integrated details of what it actually looks like when you program with Furhat. So in order to explain this, it can be helpful to sort of divide our functionality with the robot in sort of two parts. One are the sort of more basic input-output parts. So if you think of the basic input-output that the robot has, it can speak, it can do gestures, it can attend to things by looking at them, it can listen to people and detect users with the camera, and it also has LED lights that you can control. So that's the basic functionality. Then on top of that, we have something called the skill framework. So the skill framework contains functionality that allows you to build more advanced interactions with Furhat. And there we find things like what we call the flow, the dialogue flow or interaction flow. We have natural language understanding. We have something called utterances that allow you to combine text with gestures, for example. We set up OS functionality or functionality for building graphical user interfaces if you want to have a screen together with Furhat. And the most sort of powerful way of programming this is to use what we call the Skill API then. And to use that, you need to program in Kotlin. And if you do that, you will have access to all this functionality. I will go into more details about that. But the other sort of standard or sort of one of the other ways you can program is with Blockly, which is a graphical programming interface that we have. And it's similar, you do have access to the skill framework to some extent. And of course, the advantage is that it's very easy to use, but it's also limited, of course. All kind of graphical programming is limited compared to what you can do with an actual programming. And then the third way is what we call the remote API. And that's not limited to any programming language. You can actually use, I think it's over 40 different programming languages that you can use for that. But with the limitations that you only have access to this basic input-output functionality that I mentioned. So you don't have access to these more advanced dialogue and natural language understanding features and so on. So let's look a little bit more in detail. Blockly, then, as I mentioned, it's very easy to use. You have a toolbox. You can see what the different things the robot can do and explore that. And you can build reactive things, as we see here, sort of how should the robot respond to different events that come in and so on. Again, very nice way of getting to know the system and maybe used for educational purposes. But a bit limiting if you want to build more advanced interactions. The remote API that I mentioned, then you have to enable this functionality on the robot, the remote API. There's a special function for that. And then the robot goes in sort of a slave mode, which means that it will do whatever you tell it to do. And so the idea is that you run your program on a laptop, for example, connected to the robot. And if you want to use the Python, it's very easy. You can see here how easy you can get started. We have the Python package, and you just create a Furhat object, and you point to the address of the robot, and then you can start controlling the robot. And as I said, there are also ways of doing this in other programming languages. But I said it's limited to the basic input-output functionality. So with the Kotlin Skill API, you typically, what we recommend is to develop in IntelliJ IDE, and then you can use the functionality and the sort of scripting languages or domain-specific languages that we have defined to build more interactive things. And then you can run that and connect it directly to your robot or your SDK. And so you can run the program, you can debug the program, directly, and it will run directly against the robot. And you can also then compile this into a skill. So you get a skill file, and then you can distribute that file or upload that file to the robot. And the robot can run the skill independently of any other. So yeah, you don't need your laptop anymore. And you can also set it so that it automatically starts the skill every time the robot starts, for example. So that's again, if you want something self-contained in the robot, this would be the way to go. So maybe not everyone knows what Kotlin is. It's a programming language based on the Java platform. So it runs on the Java virtual machine developed by JetBrains. Integrates very well with IntelliJ. That's why we recommend that. It's actually Google's preferred language for Android app developers. So we are not the only ones who think this is a great language for application development. And some properties, it's statically typed, which means that you get warnings when you do things incorrectly while you are programming, and you also get a lot of help. So the IDE can provide you with suggestions and so on. And it has it's a bit like Java, but much more concise, you could say. So it's a bit like a mix of Python and Java, you could say. It also has something called extension functions that I will mention, and support for domain-specific languages, which is a very nice feature that we use a lot. And what do we mean by that? So one way we use this is when you define what we call state. So this state is very central to programming interactions using the Kotlin Skill API. And so basically, when you develop an application, you want your robot to react to things. So whenever something happens, you want the robot to react to that. But you don't want the robot to react in the same way all the time, of course, to something that happens. And that's why you define states. So a state defines or encapsulates a set of triggers that says how should the robot react to different things in this specific state that you're in. So we might be in this greeting state, for example. And there we can define these different triggers. So an on-entry trigger is triggered when we enter this state, where we want to ask, do you want to take part in a survey? This on response with an intent that we have provided is triggered when the user responds yes, in which case Furhat would say yes, great, and go to another state. We can also trigger when the user smiles, for example, or trigger on a custom event that we define. Maybe you want to connect your robot to an IoT device and make the robot do something when someone switches on the light, for example. This would be the way. And you can also add other triggers that add buttons to the dashboard, which is great for building Wizard of Oz interactions. So whenever you're in this state, this button will appear. So this is where to go. This is just a sample of the different types of triggers that we have in the system. Another important feature is that you can inherit states. So you can have, instead of defining all the triggers in this greeting state, you can define some of them in a parent state that we see on the right here. And then you let your greeting state inherit that state. And then you can have these triggers to be the same across different states of the interaction. So it's sort of built in hierarchical state machines. Okay, so if we want to build an interaction, we have here a fruit seller. We want to build a robot fruit seller. Then we see the example of the left. This is an example that we have as a tutorial on the website, if you want to try it out. And what we do basically is to try to identify what are the different states that we go through then in this interaction. Well, robot is in an idle state first, waiting for a customer. Then we go into some start or maybe a welcome state. And then we have a taking order state. And then anything else state where we want to see if the user wants something more. And user can add or change their order until they say no and go back to idle. So the way this works is that, yeah, we have these triggers then that sort of creates these transitions between these states. And if it's a spoken interaction, many of those triggers will be so-called on-response triggers. triggered by certain what we call intents. So when the user says something, for example, what do you have? We map that to an intent called request options here. And that will make the flow transition then to another state in this dialogue. So this way you get this kind of sort of flow chart or state machine that you can see on the right that sort of maps to the dialogue. And this is quite a nice way of approaching this if you have an interaction, is to actually write a script and try to identify the states and the intents that you expect the interaction to go through. And as I said, states can inherit each other, so it's very useful to think how these states inherit each other, because it means that you can define certain triggers on more generic levels and that you inherit. So on the top in this hierarchy here, I have placed, that you can see on the right, I've placed one intent called request repeat. And it means that regardless of which state I'm in, the user can say, can you repeat that? And the robot would just repeat the last thing it said. So this is obviously very, very useful. And the intent classifier that tries to classify the intent is smart. So if you are in the taking order state here, it collects all the intents that are relevant for that state and all the states above it in this hierarchy. And it only tries to classify the intents that are relevant for that state. It doesn't try to classify greeting, for example, unless, of course, you want to have that as a generic intent. And as I showed you before, these states then corresponds to these state definitions that you write then using this language in Kotlin. And actually the Blockly flow works in a very similar way. So you actually define them as states in Blockly also. So you have access to this flow functionality in Blockly. So it's actually very similar. It's the same structure. It's just more easy to use, but also more limited. And these intents that I talked about, so we have, for example, a buy fruit that you see on the bottom here. To define them, you can provide examples. So you say to buy a fruit, you might say banana, or I want an apple, or I would like some oranges. And then we have a classifier that sort of learns how to detect those kind of intents. And they might have entities in them, which are the specific objects here, which is in this case would be the fruit. That can be either a banana or an apple or an orange in this very simple example. But we also have a lot of built-in intents and entities, so you don't have to define those common things yourself. You can use common things like yes and no, or don't know, or maybe, or greeting, etc. And they come in a couple of languages with the platform. And also for some entities that are very common, like time expressions, date expressions, numbers, and so on. Apart from that, there are some things that, of course, are important for a robot. One is to manage users. We can see here on the left that we have some kind of interaction zone for the robot, an inner and outer. We define those with what we call an engagement policy. So you set the distances of these, and whenever a user enters the inner zone, the robots get an event for that, and you can start to interact with them. And when they leave the outer zone, you also get an event for that, so you can stop interacting with them. And you can also define how many users at the same time that will be sort of considered as users. You can also actually, if you're an advanced user, you can define those engagement policies yourself if you have some very special setup for the robot. You can control the attention of the robot, of course. So we have these different types of attend command to decide where the robot should be looking, maybe at a specific location, or at the user, or at all the users. Then it will shift the gaze between them, or maybe just glance at someone and then continue looking where it was looking before. Making gestures is important for Furhat, of course. So we have this library of gestures. Here we see big smile and express disgust, for example. And those you can easily use. We saw here in the bottom left here how you can, for example, do a smile as a reaction to the user smiling to the robot. But you can also define those gestures yourself with by programming them, or you can use a gesture creation tool that we have, and you can record the gestures from your own face. Utterances is a very nice feature which allows you to mix text and gestures or other nonverbal behavior. Like to the left here, we have hi there, and then there is a gesture smile. Nice to meet you. You can pick up your order over there, and the robot does a glance to the left. And the nice thing with this is that these behaviors will be placed at the right point in time when the robot is actually at that word while speaking, regardless of the sort of, for example, the rate of the voice and so on. So it's very nice for creating these kind of synchronized behaviors. Of course, you can create these as object that we see to the right here, and you can say Furhat say greeting, or you can even have parameters. You can have Furhat say tell price 500, and it will come out as it costs $500, for example. Extension functions that I mentioned, nice feature. So we can define more complex things using simpler things. So we might define a function called attend screen, which is actually then attending a specific location, or a function saying Furhat.greet user, which will want the Furhat to attend to the user, smile to the user, and say hello there. And then in your flow, you can just do this kind of thing that you see on the bottom left. So you can say, for example, on user enter, we do Furhat greet user, and it will do all those things. So these extension functions are very powerful. Or define new properties in the user class. So for example, we want to keep track of the user's score if we are playing a game, or whether they have played the game. So we can define new properties of these user objects, which is also another example that is very powerful. Finally, I should just mention this Wizard of Box functionality. It is very powerful. So as I said, as you see on the left, we add these sort of on-button triggers in states. And when you are in that state, as you see on the right, these buttons will appear on the dashboard. So you can sort of create a wizard interaction that is sort of context dependent on which buttons are appearing at that point. And of course, this can also, since you use these in these states, you can also combine them. So you can have some automatic behaviors combined with some wizarded behavior in the, for example, in any way you like. Yeah, so that was just a very quick overview of sort of the capabilities and the 3 different ways of programming Furhat to get an overall idea. And then Nils will go more into the details.
All right. In this tutorial, we will be creating your first skill with the Kotlin Skill API available in the Furhat platform. Let's first recap the different ways of how you can program the Furhat robot. In the bottom layer of the Furhat robot, we have the basic functions to control the speech, gestures, attention, make the robot listen, attending users, controlling the LEDs, and so on. On top of that, we have the skill framework, where you can manage the dialogue flow, define the natural language understanding, create the utterances for the robot, add wizarding buttons for a wizard of interaction, adding GUIs, and so on. This would be the bottom layer, the robot layer. On top of that, we have the SDK, where you can access these functions. The Kotlin Skill API gives you access to all the functionalities of the skill framework, and is our way of how you can orchestrate these advanced and complex interactions. The Blockly graphical programming interface also operates on the skill framework, but have more constraints due to the limitations by the graphical programming interface. The remote API accesses these basic functions directly of the robot. It is a RESTful API, so that means it's essentially polyglot. You can use any programming language to program these more basic commands to the robot. This also means then, of course, that you can program the Furhat with Python. In this tutorial, we will be focusing on the Kotlin Skill API. To prepare for this tutorial, you need to first install the Furhat SDK, and you can get access to it from furhatrobotics.com. Then you can run the SDK launcher and start the virtual Furhat, where you can now create a new blank skill project. Then open the skill project in IntelliJ, and you are now ready to start coding. To start your journey coding skills for the Furhat robot, I suggest you start here from furhat.io and go to our docs page, where we have plenty of instructions for installing and setting up and some additional tutorials. We also have, if you go to our YouTube page, if you just Google search for Furhat SDK, you will find lots of useful videos, and there's even the entire playlist here with detailed setup instructions and the more comprehensive webinar with co-founder Gabriel Skantze. The scope of this tutorial is that we will be creating a skill with the Kotlin Skill API that includes just a simple dialog flow of states and transitions. We will include some multimodal utterances, so the robot speaking, shifting its attention, performing gestures, facial expressions, and so on. We will make it a multi-part interaction, so we can have more than one user interacting with the robot at the same time. We'll try to make it a little bit mixed initiative, so both the robot or the user can be driving the interaction forward. We will not be using the more advanced and complex features of the natural language understanding of the Furhat platform or some of the more advanced features. But if you want to dive deeper into those, you can check out our other tutorials. So we have a fruit seller tutorial where we will go deeper into the natural language understanding system of the Furhat platform. You can also check out the Wolfram Alpha API tutorial in the docs page where you can learn how to connect to external APIs. Or go the other direction and try out our Blockly graphical programming interface for creating more simple interactions. You can also, of course, explore the example skills in our GitHub and our extensive documentation on our docs page to explore the Furhat platform on your own. The dialog we will be implementing will look something like this, where we will simply be greeting the user and asking them if they like a robot. Okay, here I have the Furhat SDK launcher up and running, or Furhat Studio as we are also calling it. I will select here to launch the virtual Furhat, and then I have the option to create a new skill. We have many different templates to choose from. These are all example skills from our GitHub, but in this tutorial we will be using the blank skill template. We will give this skill a name. Let's call it "Do you like robots?" When the skill is created, we can then import it into our IDE, our interactive developer environment. We recommend using IntelliJ that have great integrations with Kotlin. There we go. And we will now open the project, skill project that we just created. And create a project in IntelliJ. Let's now inspect the skill project that we've opened. To the left here we have the structure, and this is just a suggestion of a structure that we have for this basic template. You can have any structure that you want, that you prefer, or whatever makes it easy for you. We have this flow package where we put all the files that are for the dialog flow. We have another package here for settings where we put some other settings files for our interaction. But this main file is where you would start your interaction. So if you see here we start a flow, and we will start a flow by going to this start state that we have called init. So let's jump to the definition here and see what that init file contains. So this is the place when we start our interaction. We will set some specific configurations, and then the first thing we do is jump to the start of the actual interaction, the start of the flow, so to speak. And right now that is the idle state. But before we do that, let's actually circle back and look at the dialogue of the interaction that we want to be creating in this skill. We want to create this dialogue and make it into a application, a program that we can run on the robot. So we can think of this as two states at least. We have a greeting state here in the beginning, and then we have an ask question state that comes after it. But to turn this into an actual application, we might need to think about where should the interaction start and where should it end, and make it into a program that we can run essentially. So we have this init state in the beginning, and let's add an end state to the end, and we might want to have some kind of sleeping state as in between, or an idle state. And when we start the interaction, we can decide if you want to start it in the sleeping state, and we want to be able to return back to the interaction from the sleeping state again, so we can run this interaction multiple times as an application and not just as a one-time running of a script. When we created the blank skill from the template, we don't actually have a completely blank skill. There is already some structure to begin with, so we can reuse that. Let's inspect the content of this skill project. We have the flow package here, and that will contain all the files for defining our dialog flow. And we have a main package where we will be putting our main part of our interaction. Starting with the idle state here, we first have an init block that will trigger the first time you enter this state, but never again. This will handle starting the interaction, only starting the interaction when there's a user present, and having different options here when we're running it on a virtual user or when we are running it on the real robot. Second block here is the on entry block that is required, and in this block we simply will just make sure that we are not attending anyone anymore. And we have this trigger below here for a user that enters. We will attend the user, and then we will go to greeting. That will be the start of our actual conversation. This is the state definition of the state greeting. We can see here that on entry we will say or ask, should I say hello world? And since this is an ask, the robot will start its listen, start its speech recognition afterwards. And we can then define two triggers here on response triggers. So if the user would say yes, we will respond with hello world. If the user responds with no, the robot will respond with okay. This is essentially the entirety of the interaction from the blank skill template. The interaction we're going for is not that much more complex, but there are a few things that we would like to add and change. Starting in the idle skill here, I simply prefer if keeping this initiating of the dialogue, initiating of the interaction, I prefer to put it in the init state. So I will just simply move this block there. I think we can skip the handling of if using the virtual user or not. So I will rewrite this little block to make it a little bit easier to read. So let's add handling for when we have 0 user, we will go to the idle state and wait for users to enter. When we have 1 user, we will go attend that user and go to greeting. And I say attend random here. It's not really random since we only have 1 user. And then for when we have more than 1 user, let's make sure that we attend all users and then go to greeting. When we created the blank skill from the template, we don't actually have a completely blank skill. There is already some structure to begin with, so we can reuse that. Let's inspect the content of this skill project. We have the flow package here, and that will contain all the files for defining our dialog flow. And we have a main package where we will be putting our main part of our interaction. Starting with the idle state here, we first have an init block that will trigger the first time you enter this state, but never again. This will handle starting the interaction, only starting the interaction when there's a user present, and having different options here when we're running it on a virtual user or when we are running it on the real robot. Second block here is the on entry block that is required, and in this block we simply will just make sure that we are not attending anyone anymore. And we have this trigger below here for a user that enters. We will attend the user, and then we will go to greeting. That will be the start of our actual conversation. This is the state definition of the state greeting. We can see here that on entry we will say or ask, should I say hello world? And since this is an ask, the robot will start its listen, start its speech recognition afterwards. And we can then define two triggers here on response triggers. So if the user would say yes, we will respond with hello world. If the user responds with no, the robot will respond with okay. This is essentially the entirety of the interaction from the blank skill template. The interaction we're going for is not that much more complex, but there are a few things that we would like to add and change. Starting in the idle skill here, I prefer if keeping this initiating of the dialogue, initiating of the interaction, I prefer to put it in the init state. So I will just simply move this block there. I think we can skip the handling of if the using the virtual user or not. So I will rewrite this little block to make it a little bit easier to read. So let's add handling for when we have 0 user, we will go to the idle state and wait for users to enter. When we have 1 user, we will go attend that user and go to greeting. And I say attend random here. It's not really random since we only have 1 user. And then for when we have more than 1 user, let's make sure that we attend all users and then go to greeting. We have so far not inspected the idle state. And actually we said we wanted to have a sleeping state and not really an idle state. So let's refactor this. In the sleeping state here, we can see on entry, we will be making sure that we're not attending a user. And we will be waiting for a user to enter, where we will be attending the user, and then we will go to the greeting state to start talking to them. Browsing the existing gestures in the platform, we can see that we don't really have a good gesture for waking up, but we have this other source where you can find more gestures that we call the asset collection, that is part of the Furhat library. You can read more about the Furhat library in our docs page. It consists of different kind of material. What we are looking for here is what we call the asset collection. So this is a collection of extra resources, gestures, utility functions, and other goodies that you can make it easier and faster to create your skill. And you can access this asset collection by importing this jar library and by adding this dependency in your build Gradle. You can choose a specific version, or you can just use this plus sign to get the latest version of the asset collection. Let's paste this into our build.gradle file where we have all the different settings and definitions for dependencies that this skill is relying on. So next to our dependency here to the Furhat Commons dependency to the skill framework that we have, let's add a dependency here to this asset collection library. And then to the right side here in the Gradle panel, let's just refresh the Gradle project so it will download this jar file from our servers. And then we should have these new gestures available to us in our skill. So let's try that out. So me knowing the gestures in the asset collection are called gestures lib. So if we simply type gestures lib, now we have a new collection of gestures to choose from. And I of course know that in here we have one that's called perform fall asleep. So the robot will put its head down, close its eyes, and remain closed. And we have a similar gesture in the gestures lib library from the asset collection for waking up with a nice wake up gesture. So let's use that one. We could have also, of course, created our own gesture. That is a little bit too much in depth for this tutorial, but I encourage you to check out our other YouTube videos and the docs page to see how you can do that. I find it really convenient to have more assets and more things to use in your interaction in this asset collection. If you do so as well, send us a comment and tell us what other things you would like to have in the asset collection. But preferably, if you have already made something that you find would be very useful for others, we'll be happy to add it to it. And maybe in the future, we will open it up for anyone to create their own content and add it to their own library. That I think would be awesome. But I think that's a topic for another discussion. Let's get back to the tutorial and the skill at hand. Let's also inspect the parameters, the engagement parameters we have in the setting package. So we have two parameters here, the max number of users and the distance to engage. Let's increase the distance to engage to 2 meters. So it will be a little easier to get the robot to react to you standing in front of it. These parameters are referenced in the init state, where we are setting our simple engagement policy, and we are let's also define some parameters for our character. We have already selected a voice here, the Matthew voice, which is a voice from the Amazon Polly. I know there's a newer version of this voice using a neural speech synthesis, so let's change it to that. And let's also set the face of the robot. So we will select Furhat.character and let's use the more or less default face that is Alex. Okay, so now we have set our start of the interaction. We have defined our parameters, our character. So let's head into the actual conversation and let's modify that. Let's start from the beginning with our greeting state. Let's delete everything that was on here. We can add a simple save function like this. But actually I want to add a more complex one where we can have some variation to what the robot is saying. So we'll change this function here to be like this instead. So we can use this utterance builder object. And in here we can add a random function where we can add some more variation to our greeting phrase. We said that we wanted to create multimodal utterances, so let's make sure that we also include some facial expressions in this utterance block from the robot. So we can add a smile here. I'm using the one from the gestures lib that I find nice. In the docs page, you can find more information on exactly what you can put into these utterances. And I guess that goes for everything in the content of this tutorial, that in the docs page you will find the more complete, comprehensive documentation on all the different features that are available in the platform. So do check those out. And this tutorial is more or less an example of putting some of these functionalities into practice. And since we have used a Furhat say function, that means the robot is not listening at the moment. We could use an ask, that is a say and listen combined, but let's for clarity add a Furhat listen here. And now we need to define our triggers, what responses that Furhat is listening for in this state. In this tutorial we will only be using the built-in intents, and there's a built-in intent here for a greeting. So if the user replies with a greeting, we can decide what to do next. And if you remember our dialog sketch, our next move is that we want to ask the question, I want to ask the user if they like robots. Typically you would then make a transition to the asking question or asking about robots state. But I would like to demonstrate how you can also use a more simple function to ask a question and get the reply back, and then decide what to do after that. So let's add a question. If we can ask them a question, and if they say yes, then we will go to ask them if they like robots. If they say no, we will do something else. And we can do that by adding a ask yes no question and assigning the value to a boolean that will be true or false based on the user replying yes or no. Now we can create a condition. If the user replied yes, we will then make the transition to the asking state. We always want to make sure that we are handling all eventualities in our interaction. So if user said no here, we will simply just say sorry to bother you, and we'll go back to the sleeping state. We also want to make sure that we are handling if a user says something other than a greeting. So if they say nothing at all, we will actually, maybe we should not sort of stop the flow because of the person not returning the greeting, and we should continue anyway. And we can do this by raising intent greeting, so we'll behave exactly the same as if the user had replied with a greeting. And you also need to handle if the user responded with something else. So if we have a empty on response trigger, we can then define what we should be doing here. Since this is not a critical part of the interaction, we'll do the same thing with the user not responding with anything. We will just continue with the interaction as if the user had responded with a greeting. I should mention that the order of these response triggers matters, so let's make sure to have the general response trigger here at the bottom and have the more specific response for the greeting on top. Let's keep up with some good coding practices and just add some comments here so we can more easily read what's going on in this interaction. Alright, let's now implement our asking state, where we will be asking the question if the user likes a robot. So let's create a new file here. Let's call it asking. We will define this as a state. And import these functions. On our entry, we want to ask our question. Seems like it doesn't want to import the ask statement here, so let's do this more manually. There we go. Do you like robots? And now we'll trigger or define our response triggers. So the user can say response with yes, and we're using the built-in intents here that we can simply import from the dialog framework or the skill framework. An important aspect of the skill framework is, of course, that you can define your own intents, exactly what utterances, what phrases the user says that should trigger these responses. But that's not the focus of this tutorial, so we'll just stick to the built-in ones. There are a couple more that can be quite useful. We should have the don't know. So let's make sure that we can handle users that replies with that as well. And what else do we have? Maybe, yeah, let's use that one. Let's also make sure that whatever user responds here, that we can save that information on the user object that we might want to use later on. So to do that, let's go to setting. Let's make a new file here. We're going to call it users, where we can store our information about our users. And we can use this extension functionality of the Kotlin programming language, so we can define on our user object. We can add a parameter here about like robots, actually a boolean if they're like it or not. And we can use this user data delegate function to assign the data to our new parameter here. Okay, so in our asking state, we can now add, if the user says yes, they like robots, we can then store this data on the user object. So for each individual user, we will be knowing if they like robots, yes or no. By default, if the user does not respond or respond with something that we have not defined a trigger for, the default behavior is that the robot will say, I'm sorry, I couldn't hear you, and then do a re-entry to the state. Let's override this and just have a re-entry, so we will not bother the user by saying, I'm sorry, I didn't hear you, and stuff like that. We will just continue looping, do you like robots? Perhaps you want a more smart handling of this error handling, but for now let's keep it simple and simply do it like this, but at least override the default behavior. Re-entry here means that we will re-enter the state and perform whatever is the action on the on-entry block in the beginning, or there's also a specific on re-entry block. Let's see if we will find use of that later on. I think it's about time that we test our interaction. In the main class of our file, of our project, we have our main class that we can run, and this will first build the package and then run it on our virtual Furhat. So make sure that we have our virtual Furhat up and running in the background. It will take a little bit of time to build the project, and in the meantime we can hop into the web interface, go to our dashboard panel where we can monitor and test our interactions. We can see that the skill now is running from inside IntelliJ. Let's add a virtual user because I think that is necessary to kickstart the interaction.
Hello there.
Hello.
Can I ask you something?
Yeah, sure.
Do you like robots?
Yes, I love robots.
How nice.
And that's the end of the interaction. It's very useful to tick this box so you can see what intent was triggered in your skill. But we end the interaction pretty abruptly, so let's make sure that we add a nice ending to the interaction as well. Let's add a new state here in our main flow. And let's define an end state. Where we will simply be saying something to wrap up the conversation. Let's make sure to also add a gesture here because why not? And I would also like to make sure that we are signaling that this is the end of the conversation. So we should add a behavior where the robot is looking down, perhaps. So let's add to our utterance block here a behavior that is Furhat should be looking down. There should be a predefined location, so Furhat attend, and we should have a predefined location which is simply looking down. Now we'll give the user some time to catch the message, so we'll add an on-time trigger here, and let's say 15,000 milliseconds. So after 15 seconds we expect the user to have maybe left interaction, and we can then return to our sleep state and wait for another user to start a new conversation with the robot. So now we have a nice ending state to complete our interaction. We're not done yet. We have a couple more things that we would like to add to our skill project. I have so far not mentioned the parent Kotlin file that you can see here on the left. So this is a way how you can use this hierarchical function of the state chart framework to inherit more general behavior that you can store in your parent state. So let's take a look at what our parent state contains. The default parent state here from the blank skill will give you some basic user management handling. So we have two triggers here, the on user leave and on user enter. So any state that inherits this parent state will then inherit this behavior of the robot. And we can see here on a user leave, if we have if you don't have any users, then we will go to the sleeping state. But if we have users and it was that user that left, we will find another user to attend. On a user that enters, we will just glance at the user, assuming here that handling of what user the robot should be attending, that is what the robot should be looking, is handled in the flow. So let's make sure that we add this parent state to our asking state, and we can simply do that by adding that to this state definition. If we add our parent state here, this means that this state now inherits all the triggers and actions on the parent state. We can check that to see that we actually already inheriting the parent state here in our greeting state, which is good. Not in our ending state, so let's add it here as well. But I think in our sleeping state we don't want to be inheriting any of this user entering leaving behavior. We have defined our own behavior here, I guess. You can always override any action or trigger from your inherited parent state by simply adding the trigger here. So if we add on user enter and we'll define a specific behavior that should happen on user enter, this will override whatever we have defined in our parent state. We said that we wanted this skill to handle multiple users, so let's make sure that we go over the skill and in every state make sure that we are handling multiple users. We did say though that in our engagement parameter here that the max number of users is 2, so we know that the robot will never see more than 2 users. Let's start with a greeting state here, and let's make sure that we greet all the users that are present. I find the when statement to be most easily readable. So let's make sure that when we have 0 or 1 user, we will not do anything because we have already greeted them above here. But when we have 2 users, we can say something to them as well and make sure to attend them. Again, let's make sure that we add some variation, so let's add a random block for what the user should be saying here. As a default, you should always be adding variation to your interactions. And maybe a short one as well. Alright, there we go. As always, also let's make sure that we are using our face, so let's add a gesture here. Smile, I think is appropriate. And afterwards, let's go back to attending, or let's make sure that we are attending all users from now on. Even though we said there would only be maximum 2 users, let's make sure to just add an else statement here if there are more than 2 users, which it should never be, that we do something reasonably smart. So let's just glance at left and let's glance to the right and say something as if we're attending, an audience rather than individual users. When you are defining the behavior of the robot like this, make sure to always test it properly. There can be so many small differences in subtle behavior of the robot that you should be testing and paying attention to. But let's skip that for this tutorial. Next up, let's go to the asking state and make sure that we are handling multiple users here as well. So we'd like to ask each user if they like robots. And there are multiple ways how we can implement this. I will implement this in a way where we will be breaking out this asking block and these response triggers and put that in a separate state that we can call repeatedly. So we can loop over the list of users and call this question state. So let's do that. Let's call this state, do you like robots? And then we can copy paste the question here from our asking state. And we will copy all these triggers as well, or we will move all these triggers as well to our state, our state that we will be calling. Now let's create a simple looping function here that will loop over all of our users. Did I type wrong? Yes, I did. There we go. We will make sure that we are attending the user that we're speaking to. And now we will make a call to the do you like robots state. After we finish looping over the users, we will then transition to the end state. What is a call, you might ask? So there's two types of transitions you can be making between states, a calling transition or a go-to transition. If you do a go-to transition, we simply continue the flow to that new state. When we're doing a call transition, we are calling that state, we will perform whatever action is on that state, and then we will return to where we were previously. So we can now use this function to call these do you like robot states, and then we will return back to our loop, and we will continue another lap in our loop, and we will attend another user, and we will now call these do you like robot states again. And when we finish this loop, then we will do an actual transition to the the end state, where we will be terminating our interaction. Let's also make sure that we don't have exactly the same behavior for the first user as for the remaining users. So let's add a variable to keep track of if we are dealing with our first user in our list or consequent users. We will set this to false after our first iteration has completed. And we can now actually redefine our do you like robots state to be a function that will take a parameter, and that parameter will be our boolean. So let's just redefine this as a function, and let's add a parameter here which is if this is the first user or not. Let's feed that parameter that we have into our calling action. And now let's make sure to use this parameter in our prompting in this state. So as long as this is not the first user, we will say something like and what about you? But for the first user, they will not get this prefix prompt. I think this will be nice. I can see now that I forgot a very important aspect. We changed this state to be a calling state, which means we need to make sure that we are terminating this calling state so we can return to where we were previously. So let's make sure that on all these different responses, we will make sure that we are terminating this state and return to where we were previously, which was the original asking state. I remember saying something before about the fallback error handling that we added here. We defined an on re-entry, but we haven't actually defined an on re-entry block, so we would just be reusing the on entry block. So let's actually define our own custom re-entry block here. And then the question is, what should we do here? Let's make sure that we don't loop infinitely. So let's add a check here for a re-entry count, which is a variable that you have available sort of as default in the platform. You can always, of course, create your own counters, but this one comes built in. And let's just add some general handling of saying something like I didn't quite get that. And again, as I mentioned before, this would essentially be overriding the default behavior that's already in the platform. So if you don't implement any of this, there will still be some handling of when a user doesn't say anything or when a user says something that you haven't defined a response for. But as a general rule, it's always good to, whenever you're creating a state or creating a part of the dialog, you should always be thinking about what happens, if the user doesn't do as I had intended or planned in this state. And let's say we will give up here after 2 tries, or 3 tries, I guess it is. And in our ending state, let's also add some behavior here for attending other users. And I think we are good to go. Oh, I can see I forgot, I made a common mistake. It seems I forgot to add this little plus here in my utterance builder. It's a very common mistake that at least I make. Let's also check the rest of the skill project so I don't have this mistake in other places as well. All right, I think we are ready to test our now multi-party interaction. Because we have already run the main class one time before, Kotlin will remember, IntelliJ will remember that, and we can use the control panel up here on the top right to select and run that main class of this skill project again. Let's add a second virtual user, so we will have 2 users when we're testing.
Hi there. And hello there to you too.
Hello there.
Can I ask you something?
Yeah, sure. Go ahead.
Do you like robots?
Yeah, I guess.
How nice. And what about you? Do you like robots?
Yes, I love robots.
How nice. That was all I wanted to ask you. Have a nice day.
I noticed in the tester that there were maybe a delay that was missing, so let's add that in here, and then maybe 800 milliseconds, or let's go a little bit more, let's go with 1200. And then I think I'm happy with this little interaction that we've built together in this tutorial. There are, of course, many more things you can go into to make this a more interesting and a more interactive and just more complex and rich experience. I would leave that to you to continue exploring, and there are a number of ways how you can continue to do that. One is simply to keep using this skill. For example, in our users object here, we we added this parameter of if the user likes the robot or not, but we didn't really use it in the interaction. So that could be a thing you could perhaps add to the ending of the interaction here, feedbacking back, you know, how nice that you like robots, I'm a robot, those kind of things. Or continue exploring whatever you find interesting. Yes, let's wrap up and circle back to the task that we set out to do at the start of this tutorial. Let's wrap up this tutorial by circling back to the task that we set out to do. We wanted to create a skill with the Kotlin Skill API that included a simple dialog flow of states and transitions, which I think we can say that we have done, although there are of course a lot more complex things you can do with the skill framework, and having interactions and dialog states that are less linear like our interaction was. We included some multimodal utterances, adding gestures and attention behavior of the robot to the robot behavior when they're interacting with the users. We added some multi-part interaction, so our skill at least handles 2 users. We tried to include some mixed initiative interaction. Maybe we didn't go all the way there, so let's just circle back to our skill project, and I can explain a little bit more about what I meant with that. So we started our interaction, or the interaction starts from the sleeping mode here, where as soon as a user enters, we will go to the greeting state. And in the greeting state, the robot immediately takes the initiative, right, by saying, you know, hello there. And here is perhaps the place where we would possibly be able to hand over the initiative to the user. We at least have some kind of a placeholder for it here. So if the user would say something else and try to take the initiative in the dialogue, we at least have a placeholder of this is the place where we will be trying to address that. In this interaction, we don't really know what to expect the user to do here to take the initiative. So I guess we would just continue with our interaction anyway, and that's a very common way of how to deal with the user trying to take the initiative, at least for this kind of interactions that are pretty linear, and the robot has a agenda of driving the interaction forward. And lastly, we wanted to just only utilize the simple built-in intents from the NLU in the dialog framework. And if you want to dive a little bit deeper into the NLU system, I highly recommend doing the fruit seller tutorial, or simply just read up on the docs page. It's a pretty advanced system that we have incorporated into the Furhat platform, so make sure to check that out. Or check out the other tutorials that we have available there as well, that I mentioned before, the Wolfram Alpha API tutorial, we have the Blockly tutorial, and just explore our documentation and our GitHub project library. Great, I think that's a wrap for this tutorial. I hope you found it informational and perhaps inspiring even. We try to make this platform as easy to use as possible for new users and novel users. We also want to make sure that it's an advanced platform for power users out there that want access to advanced features and functions. Obviously, we didn't go into that in this tutorial here, so I encourage you to dive into our docs and be active in our community Slack to ask questions on how to do the more advanced bits that might interest you. All right, thank you so much for your attention today, and as always, don't forget to smile. All right.